Good day, everybody. My name is Jude Rens. I'm with Stellenbosch University's Eco Student Society called Ecomarties. We had the pleasure of attending a workshop hosted by Henk Stander on an introduction to aquaponics. In this workshop, he presented the slideshow, and afterwards we had a tour of the Stellenbosch University facilities where we saw the aquaponics being implemented at Vogelvon experimental farms. The presentation was threefold. First, a general introduction to what aquaponics is, and then later going into more detail on fish choice and plant choice. So for the first presentation, we have what is aquaponics. This contains a definition, mentions integrated fish farming, reasons for integrating fish into your system, the history of aquaponics, what plants need to grow, and then a quick mention of the plant varieties and fish species, which we'll go into a bit more detail later, as well as different plant production methods and things like plant-to-fish ratios, nutrient requirements, and some examples of commercial systems where aquaponics has been implemented. So what is aquaponics? Aquaponics systems are recirculating aquaculture systems that incorporate the production of plants without soil. So in the second slide, you'll see a hydroponic. So aquaponics is a bio-integrated system that links recirculating aquaculture with hydroponic vegetable, flower, and/or herb production. So aquaculture being the production of fish as your product, and hydroponics being producing vegetables, flowers, and/or herbs using water as your growth medium. Aquaponics marries these two and is a living ecosystem in itself, where the fish and plants both benefit from each other. Now, how does this all work? Within the aquaponic systems, there is the nitrogen cycle, where fish release ammonia in their waste, which contains nitrogen, but not in the form that plants need to uptake. So bacteria in the water convert the ammonia to nitrites, and other bacteria then convert the nitrites to nitrates, which plants need to grow. We can filter this out of the water and then pump the clean water back to the fish. This is just a simplified diagram of what I just spoke about, where fish produce ammonia, and then two different bacteria first convert the ammonia to nitrites, and then nitrites to nitrates, which the plant used to grow. Now, within an aquaponics system, fish feed is introduced, which the fish then convert and excrete the metabolites. Now, the bacteria within the system is used to change those metabolites to nitrates, which the plants can absorb, and the plants take these out of the system before the clean water is circulated back to the fish. Integrated fish farming is a bit different and usually just implements fish within larger systems such as animal husbandry, more as compared to aquaponics, more a side note where aquaponics has fish production and plant production at the core of its practice, whereas integrated fish farming will integrate fish as waste management, perhaps, where in this image you can see animals such as, I believe, ducks are above a lake which contain fish, where the excretes can drop into the lake and the fish can then help clean the water up. Now, there are many reasons for integrating fish into your agricultural system, such as water conservation, an increase in profit potential, and delivering a diverse range of products, both fish and plants. Now, aquaponics dates back quite a while. Ancient people saw this relationship between fish and plants and they utilized it, such as the Aztec Indians, who in the image below shows that they used raised plants on rafts on the surfaces of lakes, and then naturally the plants and the fish within these lakes would have this aquaponic relationship, a bit older than how we know it today, but it has been around for a very long time. Aquaponics as we know it today started in around 1969 with a couple, John and Nancy Todd, along with William McLarney. Now they founded the New Alchemy Institute, and their project, which was in today's terms a sort of floating earthship, which they termed the proto-ark, was an idea of a self-sufficient bioshelter where a family can produce their own food as well as their own power. and they utilized rearing fish as well to as part of the shelter, so thus integrating fish with their plant production and being the birthplace for modern aquaponics. Now, as in any other system, plants have certain physical needs that need to be met in order for them to grow. Things such as media to grow within and room to grow, the right temperature, light, water, air, and nutrients. As in any other system, a lack of these requirements will inhibit plant growth. There are many different varieties of plants that can be grown using aquaponics, such as vegetable, herbs, fruits, flowers, and even aquatic plants, as listed in these tables, but we'll go into a bit more detail later. You can also have a range of fish species which you can choose from to have in your aquaponics system, either ornamental or for consumption. Now, there are different plant production methods using the aquaponics system, namely media-based grow beds, growing power models, the raft model, nutrient film technique, and then towers or vertigrow. So first off is the media-based grow bed, and those of you who have done a bit of research or perhaps dabbled in beginner aquaponics might know this way well. It is quite well known under DIY and beginner aquaponic users. Now, the principle behind the media-based grow bed is having these tanks which contain the media which the plants grow in, and pumping the water in on the one side from the fish tanks, which then filters through the media where the bacteria sit, which convert the nitrites to nitrates, and on the other end of the tank underneath the media will be a bell siphon, which takes the water out after it's been filtered through the medium. Now, the different media that can be used include simple media such as gravel, which can be bought at aquariums or even at some other retailers, and then more expensive media such as lava rock, which is a lot lighter than gravel but also much more brittle. However, this can be advantageous for growing things like root vegetables, believe it or not, even beetroot. Now, the media-based grow bed has, like anything else, pros and cons. Pros are it works great for most hobby aquaponics, as it's easy to find the components and build it yourself. You can also grow a lot of different plants and don't just have to choose one, which is the fact for some other systems. You can also make it as big or small as you want, so it's a really versatile way to incorporate aquaponics. However, these tanks can build up anaerobic zones where the water drains, where if it doesn't drain efficiently, bacteria will build up and the tanks will need to be cleaned out every now and then. One can try and combat these anaerobic zones by incorporating decomposers such as worms, but other than that, the tanks will have to be cleaned. Next up, we have a growing power model. Now, this is one that uses multiple tiers on top of your fish tank, and the water acts as a thermal mass on the bottom. These are quite good for community-sized systems, as it's a self-contained system implemented vertically rather than having a tank and a grow bed and all these different components. You have all of them integrated into one tower. It's quite easy to find the parts and can be a fun community volunteering activity to build it together. You can also grow a lot of different types here and usually uses vermicompost as a way to add nutrients into the soil. Now, this can also build up anaerobic zones as in the media-based growing model, and the water remains dark due to the plants being on top of the tank. Here is a more in-depth diagram of what these power models look like, with the plants growing on top, water being pumped up to the very top bed and then slowly draining back down to the fish tank at the bottom. Next, we have the raft model. This model is usually implemented in hydroponics, but can be used for aquaponics as well. It is quite well known in the commercial area, and a con is that you usually can't have such a diverse crop, and it's mostly used for growing lettuce or basil. However, research and industry has shown that it is a very great system for commercial setups if you're wanting to produce large quantities of produce. Oh, another con is that the filtration system has to be a lot more advanced in these raft models than in the other models. Next up, we have the nutrient film technique, which constantly runs water underneath the little cubes of material which the plants grow in. This doesn't require any more filtration, but you don't have as many crop options as, for instance, the media-based grow bed. Lastly, we have towers, which one can also make yourself by heating up a piece of metal and using a PVC pipe and making these openings where you can grow your plants in. There's quite a bit of research going into this area, and we had the honor of seeing one of the PhD students from Stellenbosch University's tower, which they designed themselves, where they utilized the contours of the tower to drain water to the plant below it. Vertigrow is another form of tower growing, and here you can see some strawberries and tomatoes being grown in commercial systems. Now, within your aquaponics system, there are very specific plant to fish ratio, which can be researched depending on the plant or fish that you are using. So that kind of leads into the next section we'll be getting into, where you need to know what you want to grow, and from there research how these fish and plant species relate to one another. Plants have different nutrient requirements, the same as any other growing method, and require certain macro and micronutrients. Macronutrients are the more well-known ones, such as nitrogen, phosphorus, and potassium, which are usually found in most fertilizers. There are also micronutrients, such as iron and zinc, which the plants also need in smaller quantities. Now, it is very important to understand, once you've chosen which plants you're going to grow, what their nutrient mix looks like. This illustration shows perfectly that if you are lacking in one of these nutrients, even the micronutrients, it will limit your yield, even though your other nutrients might be in abundance. So it's really important to do your research and know which nutrients you need, and also to track these nutrients in any way you can. Here is an example of a nutrient mix for different fertilizers. Next up, we have examples of commercial system. Here is just a simple line diagram of what a commercial system could look like, from the fish rearing tanks to the hydroponic tanks. And then Henk told us about his visit to Switzerland, where he got to see this magnificent, enormous aquaponics system, where the aquaponics system is integrated with the restaurant, and one can grow tropical fruits such as papayas in some places called as Switzerland, and at the restaurant eat both the plants and fish produced within the greenhouse. This, of course, also is a tourist attraction and had an entry fee, so a great way to add some more profit to your system. And then another example is Hakput in Gauteng, which Henk told us unfortunately recently closed down, but they had a massive system, mostly growing lettuce on rafts, as you can see, and the system was very successful. It is just known to be very expensive to start and hard to catch up on that initial capital input. So, in conclusion, there is no reason why you can't grow your own fresh herbs, veggies, and fish in your backyard. You don't need much to start if you are a hobbyist, and you can grow your system as your interest grows. Next up, I will be discussing the different types of fish that you can implement in your system. Now that we have a better idea of what aquaponics is and the different ways in which it can be implemented, as well as some examples of successful commercial implementations, let's focus a bit more on the specifics of designing your own aquaponics system. At the heart of the system, of course, will be the fish, and it is very important to select the fish based on your area, as well as legislation and other, well, my apologies, back to choosing the right fish for your aquaponics system. Now, within these slides, we will have an introduction to choosing your fish, and then some requirements which different fish species have, such as quality, water quality profile, climate conditions, and legislation for the area you are in. We'll also go through some typical species, such as tilapia and ornamental fish, and finish off with nutrient requirements and fish feed. So, as I mentioned earlier, your first you'd have to find out what the objective is for your system. Do you want to grow fish for consumption? to sell to other people to consume yourself, or perhaps you just want to incorporate the fish into your system and have ornamental fish to sell to aquariums or keep as pets. So depending on the fish you choose for your system, there are some basic criteria you need to look at, including the water quality profile, climatic conditions, legislation in your area, the market potential for the fish you are growing, and the nutritional requirements based on the fish species you choose. That's better. So, first on, the water quality profile. It differs from species to species, but most fish are quite adaptable to small changes, but don't like sudden large variations. So it's important to find the right water quality for your fish and have that system set up before you introduce all of your fish at once. Heavy metals are toxic to fish at low concentrations, and so is ammonia, which is excreted by the fish. So it's important to have a system set up where your plants can absorb this ammonia through the nitrogen cycle we mentioned earlier, and then pump back the cleaner water, which has been cleaned of the ammonia, of course. Now, it is important to understand the climate conditions in the area which you are planning to implement your aquaponics system. Most aquaponics systems would be advised to be implemented within a more controlled space, like a greenhouse, but even then it is important to know what the minimum and maximum temperatures within your area is, as certain fish do not grow well when their range is exceeded, or could even perish if these temperatures are too extreme. After doing research about the temperatures in your area, it is also important to reach out to the local authority to see whether you require permits for the fish that you are trying to implement. On a smaller scale, this shouldn't be an issue, but I know for things like tilapia, one does require a permit. On larger scale, of course, this is absolutely necessary. One does not want to set up a big system and then have to run into legislative issues later on. In the Western Cape, Cape Nature is the entity responsible for issuing these permits, and one would have to go through an application, which Henk says doesn't take too long, but other regions within South Africa would have different bodies in charge of these permits, and they might take a little bit longer depending on where you are. Next, onto the fish species that you can choose for your aquaponics system. There's quite a large variety, but tilapia is one species that most people who have researched a bit of aquaponics would have heard of before and is used quite commonly within these aquaponic systems. Other options are trout, catfish, carp, koi carp, and goldfish, other aquarium fish, bass, bluegill, jade perch, sturgeon, and pangasius. So, onto the different fish. Number one is tilapia. Now, tilapia is a freshwater fish, but there is a species of tilapia, the Mozambican tilapia, which can be introduced to a saline environment, and we were privileged enough to see the system implemented in Stellenbosch University, where Mozambican tilapia were used in saline water, paired with a saline-loving plant, of course. And then they're currently doing research to see how these plants desalinate the water over time, but it's important to know that tilapia are quite versatile depending on the species you choose, and one can opt to have this lighter colored tilapia to have a more tropical appeal than freshwater fish. Henk even showed us some parcels of tilapia that he's seen in shops before, so it is very much a viable edible fish. Here are some contacts on where one can acquire tilapia. And then a few environmental conditions for tilapia. You can see later on is also the mention of the Mozambican tilapia, which can grow in full strength seawater. Next up we have the common carp, which is a freshwater fish. It has optimum water temperatures between 20 and 25 degrees Celsius and has like maximum limits of 3 to 35 degrees, but you'd ideally want to be in 20 to 25 degree waters. It has certain pH levels and other information that would be very specific depending on the type of fish that you choose. Next up we have catfish, which people don't tend to want to eat based on their appearance, but if packaged correctly and maybe processed into some other types of food, can be a commercial option if you choose to go this way. They are bottom dwellers and have a higher optimum temperature of 28 to 30 degrees Celsius. You can also choose to have ornamental fish, such as goldfish, if you do not want to eat the fish you are using in your aquaponics system. They prefer colder water and have optimum temperatures of 18 to 21 degrees. Goldfish, however, can grow to be quite large, and Henk advised us to know the stock density of the tank and the fish species that you are using. One should know how big your fish can get and in which conditions they will grow to be bigger sizes than you anticipated. Next up we have rainbow trout, which is a very sought after fish in the commercial industry, but is a little bit trickier to rear. Their optimum temperature is far lower, with 12 to 18 degrees Celsius, and they will need some additional temperature regulation to make sure that they don't exceed temperatures such as 27 degrees Celsius. Next up we have the jade perch, which is hardy and grows very fast, and Henk also tells us tastes really good. It has the highest level of omega-3 and it has a very high temperature range from 18 degrees Celsius to 32 degrees. Now, it is important to know that the oxygen content within your water varies as the temperature varies, and also that the ammonia levels vary as the pH and temperature varies in your water. Therefore, it is important to understand where your fish want temperature and pH level to be and to cater your water accordingly. Next up is the fish feed, as this is your nutrient input into the system. These are some places where you can source your feed, and Henk suggested some pet shops. It is important to understand what's inside of your fish feed, and here you can see a comparison of fish meal to soybean meal. It is also important to know, based on the fish that you choose, what their dietary intake of vitamin requirements are. Here is a list for trout, catfish, and carps. Different minerals are used for different functions within the fish's body, and here is a table clearly stating which minerals are used for what and where your fish can find these minerals. Here are different ingredients used within fish feed and how much is needed for rainbow trout specifically. There's also the option to completely close the circle and grow your own fish feed. It is, however, very important that you take note of all these minerals mentioned earlier and to ensure to include elements which will make sure that your fish get the nutrients they need to grow optimally. Here is a list of feed that you can grow yourself and how much is needed for trout, carp, or catfish based on the diet that you choose for them, proving that it is very possible to grow your own fish feed. When looking after your fish, it is important to know which nutrients they are not getting, and one can see this with physical implementations, such as skin lesions or darkening, could indicate deficiencies in the following vitamins. That wraps up our discussion on which fish to choose for your system, what the fish need for the system that you're putting them in, and what kind of factors you need to look at, such as pH, temperature, and stock size. Next up, we have choosing the right plants for your aquaponics system. Now, the same with the fish type. One first needs to know what you'd like to grow for, and then choose your plant. And from there, see what that specific plant's climate conditions, water quality conditions are before you can implement them into the system. So you can set up the optimal system for optimal growth. We'll also look into some market research and how to research what to grow depending on market uptake, as well as increasing your chances for sales by looking at your packaging or exporting even. Lastly, looking at the nutrient requirements of different plants and how you can ensure that your plants stay healthy. So basic criteria to look at for your plant species is very similar to fish, such as the water quality profile, climatic conditions, heating or cooling, market potential, and other types of criteria. Looking at climate and environmental conditions, optimal water quality profile for most vegetables and herbs fall within the following specifications. One can also implement methods such as active or passive heating or cooling to keep the temperature at the optimal temperature for the plant that you choose. The pH is very important as it influences a plant's access to the nutrients. The tolerance range for most plants is from 5.5 to 7.5, and they prefer a mildly acidic condition. The reason pH is so important is if you go outside of the range of your plant's pH requirements, they'll go into what's called nutrient lockout, which means that no matter how many nutrients are present in the water, the plants cannot take them up. This is especially true for nutrients such as iron, calcium, and magnesium. This graph clearly indicates where the pH uptake region is based on the nutrients in the water or in the medium. So it is important to understand which nutrients your plant needs and then accordingly draw up the pH range that you should maintain. As with the fish, it is important to know what the objectives are that you are growing for. If you're growing your own food for consumption, you might want to grow food for food sovereignty, so choosing foods with high nutritional value. However, if you're wanting to sell your produce, you might look into niche markets to find things like basil, which are more lucrative and will make you a much larger profit. Here we have a picture of Henk Stander himself in Stellenbosch University's aquaponic greenhouses, and you can see the different methods of growing. In the middle picture, he even shows that it's possible to grow beetroots using aquaponics, and not just leafy greens. Aquaponics has been proven to have a very high productivity, with hydroponic cultures being claimed to be 2 to 5 times more productive than soil-based cultures. Aquaponic systems can equal hydroponic yields, and this is also a good way of farming as it allows the farmer to monitor, maintain, and adjust the growing conditions for the plants. It's easy to ensure optimal real-time nutrient balances as you can directly check the water delivery system and the pH and temperature of the water. There's also the additional bonus of no competition of weeds and plants benefit from the higher control of pests and disease, as with the soil-based culture. Now, this is an example of a commercial system, and Henk wanted to make it very clear that market research is important. This farmer set up uptake agreements with distributors and could make plans for up to 3 years in advance about when to harvest, what to plant, how much will be needed at certain times, and what the preferred packaging is. He also knew exactly what price he would get, and having a system like this planned out in advance takes away the stress of needing to quickly plant to catch up to what the market needs, but to rather find your uptaker before the time and plan around what they need. It is important to understand the seasonality of products, and if you have a closed system such as a greenhouse where you can control the temperatures, pH, and other nutrient inputs into your system, it would be fortuitous to see when certain produce is not in season and then perhaps you being the filler in that market. making much more money than trying to sell your produce when everyone else is producing it as well. One can even opt to export should the commercial system become large enough, but to know that there are certain basic criteria necessary for exportation. Packaging is very important when trying to sell your products, and when implementing systems such as the raft method for aquaponics, it will be very easy to package your leafy greens with living roots still attached to them. Now, each plant has different nutrient requirements, as mentioned earlier, and depending on what you want to grow, you'd have to research what these nutrient requirements are. This table shows the nutrient requirements for quite a few different produce. It also mentions the EC, which is the electrical conductivity. The EC of water is used as an indication of its salt content, since higher concentrations of charged particles increase the electrical conductivity of water. It can be used to indicate which nutrients might be possible, but it isn't very accurate for every nutrient. One can also, in the same way that you can look at fish and look at their symptoms to show which deficiency they have, look at a plant and, as the illustrations show, see what your plant needs based on their symptoms. A very important topic in aquaculture systems is biological pest control. One cannot simply spray chemical pesticides, as whatever you put on your plants will filter to your fish, and you do not want to poison your fish by trying to keep pests away on your plants. Therefore, it is important to try and use biological control and even DIY methods, such as showed with the soaked orange peels in vinegar. There's also the option of using other types of biological systems, such as predatory insects, to eat the pests present on your plants rather than using chemicals. Companion planting is another important way to ensure a healthy ecosystem for your plants. It is a form of polyculture, and an example is planting marigolds along with your other vegetables to repel certain insects. There are many charts available on the internet showing you which vegetables benefit from being planted together and which plants make very good pest deterrents. Here's one such example of the tables where you can see the crop, its companions, and then which it does not want to go with or is incompatible with. There are certain beneficial microorganisms which one can introduce into your system. And that concludes our presentation. The threefold presentation took us through an introduction to aquaponics, how commercial examples are available out there, and proves that it is a very viable way to either farm for self-sufficiency or even on a commercial scale. We had a quick discussion on the different types of fish you can introduce into your aquaponics system, as well as the requirements based on the fish species. For both fish and plants, it is very important to understand what you are growing for, either for consumption, for fish, or for ornamental purposes, and with plants, either for consumption for food sovereignty with high nutritional value, or for resale and choosing plants that are more lucrative on the markets. We also went into discussion on what different plants need and the importance of controlling your temperature and pH based on the system that you choose. There is another video made available of the tour that we had after the session, where Henk showed us the aquaponics systems being implemented at Stellenbosch University's Waterval experimental farms. I highly recommend you give that video a watch to see how all of this can be put into practice.